All right, so this is lesson 13.2, conic sections. We're talking ellipses today. An ellipse is related closely to the circle. In fact, a circle is really just a special type of an ellipse. And so how do we define an ellipse? Well, we've got a lot of different points in here to look at. So an ellipse obviously is an ovoid shape where you have a major axis, which is the longer side, and then the ends of that are called the vertex, where it meets the outer edge, or the circumference. So this is your major axis going long ways, and your minor axis goes up and down. In a circle, the major axis and the minor axis are equal to each other, and so that just kind of changes everything. You have in an ellipse, you have what's called a focus. And a focus are 2 points that are always, if I add up anywhere on the circumference, the distance from each focus adds up together to be the same value. And that same value is the length of the vertex or the major axis. And so, in other words, what I'm saying is that if I add up anywhere on this triangle, anywhere on this outer edge here, this length plus this length will always be the same. And so if I had a point over here, let's go down here and make it something different, then I would be adding up this length plus this length. And again, it's going to add up to the same value. Okay, and so that's really, if you think about that, when I teach this in my engineering class, what I talk about is, imagine you have 2 pins that are stuck in a piece of cardboard or something like that, so that the pins can't move. Okay, those 2 pins are the focus points. And then I take a piece of string and I tie it into a loop. And if I pulled that string tight, it would create 2 straight lines like this. And if I continue to go around in a circle, pulling those 2 strings tight, it would create my ellipse. Okay, so that's kind of where an ellipse comes from. So the center point of my ellipse is the point H and K, just like the center of my circle was the point HK. But instead of having a radius, I have these 2 sides. Okay, so we're going to call the long side A and the short side B. Okay. All right, so here is my long side. Here is A. And remember, that's from the center over. That's not the full length of the vertex. It's half of the length. So this is also A right here. Okay, so going from here to here is A. And going from the center up to the top is B, which is also B down here. Okay, so that's really important that you understand the distinction of that. It's not the full length from end to end, but half of the length is B. So kind of think of it as a quasi-radius, if you will. Okay, now, and because again, remember, a circle is a special ellipse where A equals B, right? Then both of my vertexes and my co-vertex are going to be equal to each other, because that distance is called the radius. All right. So what does this all do for me? Well, now we've identified all the different characteristics in here. Let's look at some formulas. Now, an ellipse can be drawn horizontally, like it's this example up top, but can also be drawn so that my long side is vertical as well. Okay, like that. And so my A then would be this way, where this is A and this is my B. And this one over here, this is my A, this is A, and this is B. And so the 2 equations, versus horizontal versus vertical, are the same equation. The difference is that the longer side for a horizontal, my A side is always the longest side. Okay, so A is always greater than B. Okay, so A is the long side here. A is the long side horizontally. Okay, so my A goes under the X's for horizontal, which makes sense. And the A goes under the Y value for a vertical. Okay, so that's how you tell whether it's vertical or horizontal, is which of these denominators is the biggest. And then we have these 2 points that are the foci, if you will. All right, so I get focus 1 and 2, and the distance from the center to the foci is the same each way, right? This was negative, this one goes positive, this one would go positive up and negative down from my center. So whatever my center value is, I'm going to go along that axis, and that value, c squared, is equal to the longer side, a squared, minus the shorter side, b squared. So in this case here, it's not that c squared equals a squared plus b squared. In this case here, it's a squared minus b squared, or your longer side minus the shorter side squared. Okay, so that's all of our preliminaries. Let's go ahead and get to some problems. All right, let's start off simply. I've given you the equation for an ellipse, and first question we would want to ask is it horizontal or vertical? So let's see. Can somebody try and give me a guess on that one? Brianna, what do you think? Is it horizontal or vertical? Vertical. Okay. And why do you think that? You're not wrong. Okay. You just guessed? Oh, come on, it was a good guess. All right, where's the bigger number in the denominator? Which is the 2 bigger number, the 4 or the 49, right? 49, and 49 is under the y's. So that makes that the a. Okay, so this is, remember, my equation is x minus h squared over, and it's either a or b, whichever one's the bigger, right? Well, in this case here, this is the smaller, so this is b squared plus, and this is y minus k squared over, and this is 49, so this is a squared. Okay, so the first thing I want to do, what's my h and k values? Well, there's no value here, right? This is just x minus 0. So my center is on origin, 0, 0. Okay, so let's go ahead and drop that dot in there. And my a value is the square root of 49, right? 49 is a squared. So then a equals 7. And, you know, I know that the square root of 49 is plus or minus 7, but we're not going to have negative values in here, so it's just going to be 7. All right, so a is 7. B is 2. And now I have to do a little math to find my c value, right? So c squared equals a squared minus b squared. All right, so c squared then equals 49 minus 7, which is 42. And square root, I'm sorry, how did I get 7 out of that? I'm so sorry, that's a 4. My b squared is 4. So this is 45. Okay, and so c is the square root of 45, which is 3 radical 5. Okay, 9 times 5, square root of 9 is 3. So 3 radical 5 is good. I will accept 6.7. Okay, that's what 3 radical 5 is. Or square root of 45 is 6.7. I'll accept that. So now where is my vertices? Okay, so remember that my vertice is, since I'm going along vertically and I started at origin, my vertice value is, it's going to be on this axis, right? It's going to go up and down from here. They don't shift left or right for a vertical, right? So then it's going to be my h value, and then my k plus or minus the a. Okay, so my h is 0, so they're both going to be 0 for the x. And my y value starts at origin, in this case here, 0, and it goes up a, which is 7, and it goes down a, so -7. All right, since we started at 0. So those are my two vertices, okay? I went up 7, so 1, 2, 3, 4, 5, 6, 7, and down 7. And where do I go side to side? Well, the opposite is true for my side to side, my co-vertices, which I don't have a list for over here. I really kind of think they should. My co-vertices is my h plus or minus b, and then my k. And so in this case here, my co-vertice, and I'm just doing this to show you guys are not going to be asked to produce this unless it says otherwise. So in this case here, it's going to be -2, 0 minus 2, and 0, and 2, and 0, +2. So 1, 2, and 1, 2. All right, the only other thing I got is my focus, and so my focus starts at the center at 0, 0, and again, it also goes along that h. So it's going to be h, for my focus, is h with k plus or minus c. Okay, so h is 0, k is 0 minus c, so -3 radical 5, and 0, comma, +3 radical 5. So those points here, again, that's 6.7. So 1, 2, 3, 4, 5, 6, and change. Those foci are really up there. The longer, because this is so long and narrow. So this is, now your drawings here are going to be, I don't expect them to be any better than mine, and mine are going to be terrible. But this is what your ellipse is going to look like, long and narrow like that. Okay, good time for a question. Is everybody comfortable so far in how I found all of those points? Okay, no issues? All right, we'll move on then. All right, another type of equation you're going to get is where I give you the vertices. Okay, so 2 points along the longest axis. A great place to start is to go ahead and plot those. So I've got the vertices and the co-vertices. So my vertices are -2 and 0, so 1, 2, and +2 and 0. And my co-vertice is 0 and 1, and 0 and -1. So I could already draw my ellipse from this, and that's a small ellipse, right? So given that, what can I find from this? Well, first off, this is horizontal. That's a given just by looking at the picture. The center is at 0, 0. What's my A value here? Well, the distance from the center to the end of my vertices, right? And so if I put this on a number line, oh, now it looks like I'm taking my pulse. If I put that on a number line, here's my 0, and I go to -2 and 2. My A value here is 2. Okay, that's the absolute value between these two. So A is 2. The same holds true for my co-vertices, which are at 1 and -1. So that B value is 1. And so now C squared is 2 squared minus 1 squared. So C squared equals 4 minus 1, which is 3, and so C equals the square root of 3. All right, so now what is my, okay, so my square root of 3 is 1.7, so I'm right here and here for my foci. Okay, don't really need those for this as far as drawing is concerned, but my foci are going to be along this x-axis again, so I'm not going up or down, so that's not going to change, and so my h value was 0. I'm sorry, my k is 0, so it's going to be negative radical 3 and 0. and positive radical 3 and 0. So what does my equation look like now? Well, I've got all of the parts in here. So it's going to be x minus 0, so x squared, over, and I'm horizontal now, so my a is going to go under the x squared. So a squared is 2 squared, so that's 4, plus y squared. And y squared is over 1, but I'm going to keep it there anyway, even though I don't normally write y squared over 1. 1 squared is 1. And then that equals 1. Always has set equal to 1. Okay, so that is your full problem there. If they give you the vertices, this is actually, I made that a lot more complicated than you probably could have done all that in your head. All right, let's kick it up a notch. All right, so in this problem, I'm going to give you the axis length for the major axis and then the two foci. Well, what does that give me? Well, first off, if I have a major axis length of 8, then A is half of 8, right? It's 8 over 2. So my A value is 4. All right, that's helpful. What else do I know? Well, in this case here, I know the foci is equidistant from the center, right? So the center is going to be halfway in between these two. All right, so it's halfway in between these two. So I'm going, well, let's go ahead and put those points in there. So 0 and 1. So 0, 1, and 0, 5. So 1, 2, 3, 4, 5. Now remember, this is not my vertex. These are foci. My vertex are going to be further up and down from here. But I can find my midpoint is halfway in between, right? And so halfway in between 1 and 5 is 3. Again, if I use the number line. All right. You could also take 5 plus 1 and then divide it by 2. So I get 3 there, okay? So what else do I know in here? Well, let's see. Oh, I could find, what's the length of C, right? Well, C, this distance right here is C, and this is C. So C equals 2. Now I can find B, all right? Because C squared is A squared minus B squared. So C squared is 4 equals A squared is 16 minus B squared. A little bit of algebra here, and I get B squared equals 12. And so B is the square root of 12, or 4 radical 3. 2 radical 3, sorry. 2 radical 3. Because I pulled the 4 out. Okay. So B is 2 radical 3. So my vertex is the center. All right, well, where's my center point? Well, this is the center. We already said that. So that's 0 and 3. So my vertex is going to be 0 because I'm vertical. So 0, and then it's 3 plus 4 and 3 minus 4. So let's go to -1 and 0 and 7. Okay, and so those points then, let's go ahead and do a different color just to liven this up a bit here. Okay, so going up to -1 and 7. 1, 2, 3, 4, 5, 6, 7. And my B value, again, that 2 radical 3 is 2.46. So 3.46. So let's call that 3.5, right? So 3.5 from here. So 1, 2, 3 and a little. 1, 2, 3 and a little. This is almost a circle, not quite. All right. What's my equation look like? Well, again, I'm not going to rewrite it again, but it's x minus 0, so x squared, over, and I'm vertical, so my b is going here, right? All right, let me clean this up again. It's x squared over the b value. And my b is 2 radical 3. But that squared is back to 12 again, right? So I'm x squared over 12 plus, and y minus 3 squared over, and then 4 squared is 16 equals 1. And you can see how close these two values are. 16 and 12 are pretty close together. That's why this is almost circular, right? For this value up here is 4. This is 3.67, really, really close together. Okay. All righty, so I think this is the last one of these I'm going to give you. It's a little bit more typical of what you will see for one of these problems. Okay, so just like we did with the circle, we're going to group, complete the square in order to solve this problem. All right, so I have the x's here, and they both have a common value here of 4. So I'm going to factor 4 out of here at the same time. So this is going to be 4. And then x squared minus 2x plus some value, and then that's plus my y squareds. I can't factor anything out, so y squared plus 4y plus some value equals 8. And what I did here is I went ahead and added 8 to both sides ahead of time here. Okay. All right, so how do I find this? Well, remember, complete the square, right? So I take b, which is negative 2, divided by 2 becomes 1, and then I square it. So this is 1, right? 2 divided by 2 is 1, 1 squared is 1. 4 divided by 2 is 2, and 2 squared is 4. Well, if I add this here, this is 4 times 1, so plus 4. And here I just added 4, so plus 4 again. So let's go ahead now. So this is 4, and then it's x minus 1 squared, and then y plus 2 squared equals 8 plus 4 is 16. Well, remember in my basic equation, I set everything equal to 1. So to get there, I'm going to divide everything by 16. So this is divided by 16, and this gets divided by 16. And so my new equation, to cancel this out, becomes 4. And so my equation, I'm going to write it over here, is x minus 1 squared over 4 plus, and then it's y plus 1 squared, or 2 squared, sorry, all over 16, and then that equals 1. Okay, so a equals the square root of 16, so that's 4. B is the square root of 4, so that's 2. And then 16, so C equals 16 minus 4 is 12. We've seen that before. So C squared is 2 radical 3. My vertices, okay, so I need the center point of this first is 1 and negative 2. And my vertice then is going to be, well, my vertical or horizontal. Okay, I am vertical, right, because my 16 is under the y. And so my y value is what's going to change. So this is 1, comma, and then negative 2 minus 4, so negative 6. And then 1 and negative 2 plus 4, so it's positive 2. Okay, let's go ahead and plot what we know so far. So 1, negative 2. And my vertices here at -6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, right there. And let's see, my foci are going to be, well, we already said that it's 1. Then my k is -2 minus, and I'm going to rewrite, I'm going to use the digital value here to make this easier. So 2 radical 3 is about 3.6. All right, so if this is 3.6, then I'm going to subtract 3.6, -2, and 3.6, and so that's going to be -5.6. And 1, and 3.6, positive 3.6 plus that is going to be just 1.6. There's my foci. So what are my B values here? Well, B we know is 4, is 2, right? Square root of 4. So from the center point, I'm going to go left and right 2 spaces. Right there. And so now I could draw my ellipse. Okay. Have I answered all of the questions on this page? It looks like I have. All right, that is the last of these.